So something to note is that the reagent is phenyl ethanol. Let's first write the structure of phenyl ethanol. Phenyl means that there is a benzene ring attached to something, to that compound. And what is that compound? Ethanol. Ethanol means an alcohol with 2 carbon atoms. So we have, this is ethanol, but with a benzene ring attached to it. That is phenyl ethanol. Ethanol rather. Then we are converting it to cyclohexyl ethanol. Cyclohexyl ethanol. Now, cyclohexyl is an alkyl group having 6 carbon atoms in a ring. This is what we mean. Cyclohexyl is an alkyl group, which is this one, having how many carbon atoms? 6, because of hexa. So 1, 2, 3, 4, 5, 6 carbon atoms. But where is it attached? Where is that alkyl group attached? To ethanol. Ethanol, when you hear on, ethanol, it shows you that it is actually a ketone. But of how many carbon atoms? Of 2 carbon atoms from ether. Okay? So we have cyclohexyl group attached to ethanol. That is cyclohexyl ethanol. Now, what we have to notice is that we have actually 2 things to do here. One, to convert this alcohol, ethanol, to ethanol. And to convert an alcohol to a ketone, you actually need to form a secondary alcohol first, if it is a primary alcohol. So this is a primary alcohol. We need to first convert it to a secondary alcohol. Then we can oxidize it to a ketone. Then the other issue is we need to remove this ring so that we remain with no ring inside that cyclic compound. How do we remove? We already know. Hydrogenate it. Hydrogenate the ring. Okay? But now you have to hydrogenate strategically so that hydrogenation doesn't affect any other compound you have formed. So we start by converting this to this ethanol to ethanol. How? We first have to dehydrate it using concentrated sulfuric acid at 170 degrees Celsius to 180 degrees Celsius, and we form an alkene, okay, which is called phenyl ethene. Then to convert phenyl ethene to a secondary alcohol, we just need to add acidified water and we heat. Then we shall have a secondary alcohol formed there. Okay. Then this secondary alcohol, we can now convert it to a ketone. But if we form a ketone before removing this ring, you realize that that ketone, when we are reducing, when we are hydrogenating, will be converted back to a secondary alcohol. So we now first have to hydrogenate this before converting it to a ketone. So we have hydrogenated using 3 molecules of hydrogen in presence of nickel catalyst at 200 degrees Celsius. Then we have removed the ring. Once we have removed the ring, we can now oxidize this secondary alcohol to a ketone. How? We use manganese 4 oxide or potassium permanganate or potassium dichromate in presence of acid, okay, and we heat. Note that the order of the reagents is like this, okay. So we form the ketone. So the trick was actually here around this area, that you cannot first oxidize this secondary alcohol to a ketone, because if you now want to, after you have formed the ketone, you want to remove this ring, and by hydrogenation, then you are going to actually instead hydrogenate or reduce that ketone back to a secondary alcohol. So to avoid that, first remove the ring at this stage, then you oxidize later. Okay, so you have there an assignment. You have benzene sulfonic acid, you are converting it to cyclohexane-1,2-dihol. Dihols, remember, are formed from alkenes. So you have to find a way of converting this benzene sulfonic acid to a cyclic alkene, which is actually cyclohexane. Then you can now oxidize the cyclohexane to form cyclohexane-1,2-dihol. Then you have benzoic acid being converted to cyclohexane, rather to chlorocyclohexane. So there is a chlorine atom here. You must convert first benzoic acid to benzene and then chlorinate the benzene, then after reduce the chlorobenzene. Okay, then sodium benzene sulfonic acid to cyclohexene. So still you have to convert this sodium benzene sulfonic acid to phenol. Then after that, you can remove the ring to form cyclohexanol, then dehydrate the cyclohexanol to form cyclohexene. Then you have that unit number, and that will mark the end of benzene related reactions. So in the next lesson, we shall now look at derivatives of benzene. Thank you for watching and listening to this lesson, and may God bless you.